Okay, so what we're going to do now is we are going to look at solving equations in two variables, and that will hopefully allow us to see the connection between the idea of solving equations and graphing more clearly. So we know what solutions look like for linear equations in one variable. And what do solutions look like for linear equations in one variable? Well, they're just a single number, really, right? So this was not a solution, but this was a solution. So a solution for a linear equation in one variable, it's just a single number. Now, another thing about linear equations in one variable is that there is only ever one possible solution for a linear equation in one variable. You won't get multiple solutions. So let's go one step further. So one step further, we're going to look at linear equations in two variables. So for a linear equation in two variables, let's look at an example. Let's say we have something like x minus y equals, let's say it equals 10. Yeah, let's just say it equals 10. So what we can do here is we can ask questions. We can say something like is, let's say, 12 and 3 a solution? Already we can see that the possible solution I've presented to you looks different than the possible solution that would exist for a linear equation in one variable. Right? For a linear equation in one variable, we can only have one possible number that we could try as a solution. But for linear equations in two variables, we give two possible numbers, or in other words, a pair of numbers as a possible solution. Specifically, it's not just any old pair of numbers. We call this an ordered pair. And the reason we call this an ordered pair is because the order matters here, right? If we say, is 12 and 3 a solution, that would be what we call distinct or different from 3 and 12, right? So if we have an ordered pair, what we really mean here is that this possible ordered pair, would not mean the same thing as the same two numbers just reversed. They are not the same. They are not the same thing. They are not the same mathematical object. You can have what are called unordered pairs, but we're simply just not going to study those. So we will only study ordered pairs where order matters. How specifically does order matter here? Well, how this matters is the number that you list first is always going to be the number that you plug into your x coordinate, and the number that you look at second, the number that is listed second, will always be your y coordinate, or the value for y that you plug into the equation. So let's look at this ordered pair. Is it a solution? Is it a solution? Well, we can plug 12 into x, because the first number you always plug into the x variable, and then we can plug 3 into y, and we can see if we get a true statement. So let's give it a try. I'm going to rewrite this equation here. I'm going to rewrite this equation, but instead of writing x, I'm going to write 12. I'm substituting the value 12. And then instead of writing y, I'm going to write the number value 3. Right? That's where we're plugging these numbers into. And the question is that equal to 10? Are we going to get the same number on the left side that we would get on the right side? So what is 12 minus 3? It is 9. And is 9 equal to 10? No. We get a false statement here. This is false. False. So what we can say here is that absolutely no. No, this is not a solution to this particular equation. Let's try another potential solution. So let's try maybe and let's write this in black, is the ordered pair 15 and 5 a solution to this particular equation? Let's try it out. We're going to plug 15 into our x variable, and we're going to plug 5 into our y variable. So rewriting the equation, instead of writing x, I write 15. Instead of writing y, I write 5. So I've just plugged these values in here. And is that equal to the right side, which is 10? Well, 15 minus 5 is 10. So I definitely see the same number on my left side that I do on my right side. So if the left side of the equation is equal to the right side of the equation after you plug those values in, then absolutely yes, you have a solution. So here we have found a solution to our linear equation in two variables. But this isn't the only solution. There are in fact an infinite number of ordered pairs or solutions to this two-variable equation. There are an infinite number of solutions. So let's try one more. Is the number 20 and 10 a solution? So let's try that out. Where we see x, when I'm rewriting this equation, where I usually see x, I'm instead going to write 20. And where I see y, I'm instead going to write 10, this y value that I've been given in the ordered pair. And we subtract these two numbers from each other, 20 minus 10. And is that equal to 10? Well, I'm sure you can predict, absolutely yes, 10 is equal to 10. The left side is clearly equal to the right side here. We got a true statement, so yes, we have found another solution. So we found more than one solution, and in fact, you could find an infinite number of solutions to this particular equation. I'll give you another solution to this equation. So another solution to this equation could be, it could be 11 and 1. Right? 11 and 1 is a solution to this equation because if I plug 11 into x and 1 into y, 11 minus 1 is 10. So that would give you a true statement. You could plug in 9 and negative 1. Right? That would be another solution that you could have here. You could plug in 5 and negative 5. And that would be another solution, right? Because if you plug 5 in for x, and then you subtract the value for y, which is negative 5. Is that equal to 10? Is that equal to 10? Well, 5 minus negative 5 is the same thing as saying 5 plus 5. That is 10. The left side is equal to the right side there, so you have another solution. So that's what solutions look like for linear equations in two variables. This is what solutions look like for linear equations in two variables. They're pairs of numbers, specifically ordered pairs. The x value comes first, the y value comes second. So they look like ordered pairs, and really we can find an infinite amount of them, right? This was a solution right here. This was a solution right here. This is a solution. This is a solution. This is a solution. And we have an infinite number more. So that's what solutions look like for linear equations in two variables. And in the next video, we're going to finally make the connection between these kinds of solutions and graphs. See you then.